some cases, both the numerator and the denominator are going to have a common factor that can get canceled out and simplified. Kind of like when we were adding, subtracting, multiplying, and dividing these rational expressions. If you had the same thing in the numerator and denominator, you canceled it out. But you did have to worry about extraneous solutions in the denominator, right? Because you can't divide by 0. That is very similar to this, putting a hole in the graph. So you're going to have these graphs, they're going to be gorgeous. They're going to look like just regular lines, but there's going to be one little, imagine like a hole punch, just took a hole right out of that graph. That hole is going to come in the denominator of the original part if it was eventually canceled out, kind of like that extraneous solution stuff. So check this out. Identify holes in the graph of f of x equals x squared minus 4 over x plus 2, and then graph. So if we were to factor this, the numerator would factor to x plus 2 times x minus 2. Now, if we simplify that, they both have a common factor, the x plus 2. So what we're left with is f of x, which is the same as y, equals x minus 2. Now we can all graph that stuff. You did that earlier in the year. That's just slope-intercept form. So you would start at negative 2, down 2, and then the slope is 1. So you'd go up 1 over 1, and you'd have just a straight line like that. And that's great, but there's a hole. And the hole comes in down here. If it says x plus 2, there's going to be a hole at x equals negative 2. So even though it was canceled out in the final product, there's going to be a hole there. So here's the graph for f of x. Well, here's not the graph. There it is. There's the graph for f of x equals x minus 2, or y equals x minus 2. There's going to be a hole at x equals negative 2, which is right over here, but on the line it would be there. So it looks like a dot, but you just have an outline, like the letter O, like a hole, right? So when you graph your line, you just make sure you put an open circle on that hole, okay? Now again, that only happens when the denominator gets canceled out with a common factor in the numerator. So if this one's saying identify the holes, you know there's a hole, you know it's going to be a common factor with the denominator, which it says x minus 2. So you know the hole is going to be at positive 2. But hey, let's pretend like we didn't know that. Let's pretend like you guys aren't the smartest humans that I've had this semester. Okay. So if we were to properly factor, look at us properly factoring. Factors of negative 6 that add up to 1 would be positive 3 and negative 2. So x plus 3 times x minus 2 over x minus 2. The x minus 2's will cancel out, and we're left with f of x equals x plus 3, which is you start at 3 and then you go up 1 over 1. That's great. But don't forget, Mr. Plant, there's going to be a hole at x equals 2, right? Because that would make the denominator 0. So x equals 2 is over here to the right 2, so we find that place on the line. Boom. You got yourself a hole at 2.5. All right? It's almost too easy around here.